Okay, number one, surface integral. The first thing is understand the interpretation of this. Like always, integral is a Riemann sum. We have one function, a scalar function. F can have different values depending on the x, y, and z. We have surface. The equation for the surface is this. Suppose this representation. So in any point, we can associate one elementary surface area and one value of that function. Multiplication this value times the elementary surface area and doing the Riemann sum give me like a mass. Suppose that this is the density function of the surface. Okay, it's a little bit different to the mass of the solid because solid is 3D. This is also 3D, but this is a shield. So the thickness is 0 or almost 0. Okay. Okay, now suppose that we are doing to compute the surface integral. We convert to the double integral. Okay, you assume parametrization. One possibility, depending on the nature of the surface, is the graphic parametrization. You suppose that x and y are parameters. You replace everything, x, y, and c is like a function x and y inside the function. And ds, the formula for ds is this, that we see before in the surface area computation. Okay, and you compute this double integral. The most important is that the region, domain, in this case is the shadow of the surface on the x-axis, because you select x-y axis, x-y axis, x-y plane. This is the shadow, this is t. Of course, in general, we can projecting in another plane, cx, cy. The only thing it changes the order, no, of the variable inside the surface integral, but it's the same idea. Okay. Okay. In the general parametrization, the surface is defined using vector value function. In general, I call u and v the parameter. Well, not necessarily always u and v. Suppose that we are doing in cylindrical, or we are doing a spherical coordinate, we can use on the classical phi, theta, r, depending. Let's see example after that. That's my surface integral. We can compute it using general parametrization. So you express the integral only using u and v. Okay, and you perform the double integral onto the domain. D is the region D. But the problem is now you compute here the ds, and the ds is the cross product, the actual value cross product, magnitude of the cross product of the partial derivative r with respect to u and partial derivative r with respect to b. Magnitude and multiplication du dv, and you compute this double integral on the region D, and this is equivalent to the surface area. Let's see example now. Okay, that problem, example 1, is compute the surface integral on the surface is defined by the plane. This plane lie in this interval from 0,3 and 0,2. This is x, this is y. Look at this case in 3D. This is the plane exactly bounded by this. Entonces, si we are using, for example, the graphic parametrization, the shadow is D. D is the domain for the parameter. Entonces, the parameter que we suppose is x and y, only x and y. So we can compute this like a double integral in the region D is this, of the x squared y. Entonces C is no C, because we need to express everything using the parameters x and y. C is equal 1 plus 2x plus 3y. Okay, now we compute this ds. ds is the formula. This is square root gx squared plus gy squared plus 1 dx dy. This is ds. Partial derivative with respect, g is this. This is g. Partial derivative this with respect the x is 2, and 2 squared 4. And partial derivative this with respect the y is 3. 3 squared 9 plus 1 dx dy. So ds is equal square root 14 dx dy. Okay? Entonces, what is the limit of the region D? The limit is, suppose que you integrate, it doesn't matter the order. The order is integration, in this case, is a rectangular. Your integration in any way. Okay, rectangle D is something like that. X, Y. A rectangular is a 3, is a 2. Integration, for example, in this direction. X first, 0 to 3. And after expand in this direction, 0 to 2. Okay? Now the rest is calculation. This is long. We always omit this idea, but we are using now with the graphic calculator. Look, in my graphic calculator I put a double integral, and the answer is 171 radical 14. The answer of this surface integral is 171 square root 14.